Single Level Material Requirements Planning, or MRP, is when we look at the finished product and figure out the quantity and timing of production or purchase orders for components, assemblies, parts, materials that go directly into that finished product. So there's just a single relationship, the finished product and those things that directly go into that final assembly. Single Level MRP, or Material Requirements Planning, is an automated planning process. It takes care of many of the tedious calculations that are required to plan for production of materials. What MRP does is suggests production and purchase quantities as well as the timing. So it generally does not make final decisions, but make suggestions based on parameters that are specified that help a material planner make the final production and purchase decisions. Customer demand always drives material requirements planning. If there's no customer demand, there are no requirements generated. There are no purchase or production quantities generated. If there's no customer demand, MRP will not suggest any production or purchase quantities. Customer demand can be actual demand, actual customer orders, or forecasts of customer orders. MRP uses planning parameters that we as material planners specify, such as lot size. If we're going to make a quantity or order a quantity of materials, what should we order? Also the lead time. How much lead time should we allow for production quantities or purchase quantities to make sure things are done in a timely fashion? Basically, MRP hates negative inventory balances. When you have demand that will cause a negative inventory balance, MRP will then suggest production or purchase orders when asked. There's a planning process, so it's not continuous, but you request an MRP plan. If there's going to be somewhere in the future a negative inventory balance, MRP will suggest the purchase or production quantity and the timing to alleviate that negative demand. What MRP creates are planned orders or purchase requisitions depending on the situation. A planned order is simply that. It's a recommendation or a plan. Suppliers, production people do not see planned orders. It's only the material planner. If we're talking about something that's made internally that the company makes, planned orders can be turned into production orders. Production orders are actually orders that are issued to the shop floor. Frequently, instructions, drawings, diagrams, checklists, quality checks. Materials are produced and printed or provided via computer terminals to track the production order. Planned orders are not seen by production people. They're not a permission to make a product. Planned orders can also be converted into purchase requisitions. This is not done in this course to simplify the process. But in practice, usually you would create a planned order for things that are purchased externally to the company. The reason you want to do that is the material planners tend to come up with the plans. Once they're ready for something to be purchased, they know the quantity and the timing. They create a purchase requisition. The purchase requisition is a request to the purchasing department to purchase that material. Purchasing will take that requisition and create a purchase order. Some of the things they'll do is select a particular supplier for that order. They may adjust something in the timing as well. So for materials that are purchased, in practice, planned orders are created so that the material planner can make adjustments, combined orders, change quantities, change timing. They will convert that to a purchase requisition, which then authorizes the purchasing function, the purchasing personnel, to create a purchase order, which is a document that goes external to the company and requests the items to be delivered in a certain quantity and on a certain time. Perhaps the most important thing to remember about material requirements planning is that capacity is not considered in the basic calculations. There are tools that can be used to evaluate different plans at different levels, at more aggregate levels or more detailed levels, to evaluate capacity. They're difficult to implement and frequently not done due to that complexity. It's up to material planner to look at plans and look at production orders and decide whether there's a capacity issue and how to deal with that. But the basic MRP calculation does not consider capacity. MRP does not occur automatically. What's required is a planning run. A request to MRP to calculate material quantities. Back in the 1960s and 70s, when MRP was first developed, computers were very limited, and these planning runs were likely done once a week over the weekend, taking most of that time to calculate, and a company would work off those plans for the entire week, even though they were getting less and less valid. Now, computers and computer systems are capable enough that even for complicated products with millions of parts, MRP planning runs can be done on a regular basis so that plans are kept up to date. The planning run will produce one of two things depending on whether something is made in-house, in other words, something we make, or it's externally procured, it's something that we buy from a supplier. If we make it in-house, it will create a planned order. Again, as described, this is a recommendation from the planning system. The material planner will perhaps adjust the quantity or the timing and convert that into a production order, which is what's seen by the shop floor people. If something's going to be procured externally, the planning process can create a planned order or a purchase requisition. Typically in practice, it would create a planned order so that the material planner might make some adjustments once they look at the results of the planning run. If the planned order is created, it's converted into a purchase requisition. Purchase requisitions are then converted into purchase orders by people in the purchasing function. The people are responsible for communicating with our suppliers and working out terms and conditions. So every time a planning run is executed, if there's a negative inventory balance, planned orders or purchase requisitions are created. MRP systems implement the basic law of MRP, the basic equation, which is that beginning inventory, what we have on hand, plus whatever we produce or purchase, depending on whether it's something we make internally or something we purchase. And in some cases, parts are both made internally and purchased. That total is what's available to meet customer demand. So when you subtract off customer demand, what you have left is the ending inventory. That's the basic material balance equation. What you have plus what you make minus what you use is what's left over. The beginning inventory is the stock of material that's on hand and is immediately available. Sometimes you have materials that have come in from a supplier, but they're waiting for a quality control check, or you might have materials you purchased, but there's a quality issue and they need rework. Those are not included in the stock on hand. Demand comes from two sources or is brought into the system in two different ways depending upon the environment. A make-to-stock environment is an environment where the product needs to be available for the customer to purchase. So when you go into a retail store, a Walmart, Walgreens, you expect the product to be on the shelf ready for you to purchase. That's a make-to-stock environment. In that case, demand comes from a forecasting process. So you're forecasting the demand from the customer, you're balancing that against your available capacity and making plans that drive your production so that you have the material available for the customer. So beer is an example of a product that's a make-to-stock environment. The customer expects it to be there when they come into the store or when they go online. Make-to-order environments are for more expensive, more complicated materials. Actual demand or customer orders are used to drive the process. So as an example, aircraft are not purchased off the shelf. Companies like shipbuilders and aircraft manufacturers, in fact, evaluate their company based on their back order, what they have in the pipeline for customer orders and customer plans. The key tool to look at material plans is the stock requirements list. This is an SAP term for their particular screen, and a similar version of this screen is used in ScrimmageSIM. What the stock requirements list does is display plans for an individual material. An important feature of the stock requirements list is that it's a list or a report for a specific time. This is not a real live feed into the system that updates automatically. It's a snapshot of what the current situation is. To get new data, you need to hit the refresh button, either in an SAP system or the simulation, to get new information. In practice, material plans don't change that dramatically. We're talking about plans that are changing on an hourly or a daily basis, so having real-time information is not critical. What you have for the stock requirements list is the particular material being displayed, and in the beginning you have the stock, which is what's on hand. In this case we have 2,564 cases of beer available, ready to sell. If you were to run MRP at this point and ask MRP what should happen, nothing will change because there's no negative inventory. MRP only makes recommendations when it forecasts or sees a negative inventory balance. At that point, it will recommend quantities and timing to either purchase or produce material to avoid that negative inventory. As mentioned previously, customer demand drives the material requirements planning process. It's only customer demand that will deplete inventories and create a negative inventory balance. For the make-to-stock environment, demand comes through a process of forecasting and then evaluating those forecasts in terms of capacity and company strategy in a process known as sales and operations planning. The result of that sales and operations planning process is the creation of an independent requirement. It's termed independent requirement because it's really independent from the company's perspective. It's the demand from the customer that we don't know and have to plan for. In this case, rather than creating the independent requirement through a sales and operations planning process, we will manually input an independent requirement. So we're going to put in a quantity of 3,000 due on January 31st of 2020. When we create the independent requirement, the simulation will automatically change that to a negative quantity. The pencil icon or the change icon will allow you to change that quantity. At this point, you need to leave the negative sign in there. When you're originally creating it, you do not need a negative sign. But if you're going to adjust this quantity, you need to leave the negative sign in there. If the date needs to be changed, that can't be done directly. What has to happen is that the independent requirement is deleted using the delete icon and a new independent requirement is created. With the independent requirement, we can see that we have 2,564 cases of beer available on January 1st. On January 31st, we think we will need to have at least 3,000 cases of beer. That would put us in a negative situation of 436. At this point, we can ask MRP's advice by running MRP and seeing what it will recommend we do to make sure that we don't have a negative inventory balance. In other words, to make sure that we don't run out of beer. After running MRP, we can see that it's created a planned order, in other words, a recommendation that we produce beer. The quantity it recommends is 1,240 cases. That will bring our balance to 3,804, and the date that it recommends this planned order being completed by is January 31st, the exact date that we specified that we need 3,000 cases of beer, which will leave us with an inventory of 804. How MRP came up with this decision was based on some basic logic, the basic inventory balance equation, but also some things we specified. First of all, lot sizing. As you may remember, the fermenters at Arborcrest Ale Studios produced 12,000. The fermenters at Arborcrest Ale Studios produce 1,240 cases for each complete fermenter batch. So we have specified a lot size of 1,240 units, so that in this planning run, rather than recommending 436 units to exactly meet that 3,000 requirement, the planners have specified that if you're going to run a batch of beer, run an entire fermenter quantity for efficiency's sake. Also, the date shown in the display is when it should be completed. In other words, when the production order should be finished. To see the date when it should start, we can look at the details by clicking on the detail icon, and we can see that if we start on the 16th, we should be done on the 31st because the lead time is 15 days. What MRP does is says, you need it by the 31st, let me count back 15 days. There's 7, there's 14, this is 15 days prior. It says if you start on the 16th, you should be done exactly on the day that you need it. One of the things a material planner may do is say, we're really not busy, something may come in the future, let's move this order back and start it a little bit sooner because we have available capacity. That's the type of decision that a material planner makes once the recommendation from MRP is presented. There are a number of parameters in the MRP planning process, but the two most important ones are lot sizing. if we're going to produce or purchase something, what quantity should we use, and the lead time. How far before the date that this is required should we start the purchase process or the production process? Lot sizing is frequently determined by economic considerations. The economic order quantity and the economic production quantity are tools that can be used to assess the quantities that should be produced if we're going to make a batch of product or procure raw materials. However, there are other considerations like manufacturing process. In the case of beer, we want to use a complete fermenter quantity, not just what's needed. Or logistics, we may want to ship a pallet, truckload, case quantity, rather than the exact quantities calculated by the model's EOQ or EPQ. Lead time for an item produced in-house, something we make, is primarily determined by the manufacturing process, but it's also affected by the workload in the production facility. If the production facility is busy, there may be excessive waiting time, which will delay the production of the item. MRP does not explicitly consider capacity. Again, there are capacity planning tools that can be implemented, but many companies do not get to that level of sophistication. So what happens is the material planner should have an understanding of how busy the facility is and make adjustments to the order release times based on their understanding of capacity in the situation. For items produced in-house, again, a lot of this lead time is composed of waiting time. We're talking about production processes where we're measuring the lead times in days. So it's frequently a batch or a flow process where a batch of parts or material goes from one work center to the next, and frequently is waiting in line with other orders to be processed. So it's not unusual for 80 or 90% of the lead time for a manufactured product to be waiting time rather than actual machining or processing time. For purchased components, the lead time depends on the supplier capabilities, how long the supplier is going to take to produce something, plus the time required for transportation, which, depending on weather situations, strikes, and other issues, can be variable. For lot sizing, the fixed order quantity procedure is typically used when the order quantity is best determined by manufacturing or logistical considerations. With FX, the system will create one or more planned orders of a fixed quantity to meet the demand. To see this, let's change our independent requirement to 5,000 units instead of 3,000 units. If we change the independent requirement to 5,000 units, we'll see this quantity change. Our planned orders not changed because we haven't asked MRP to give us new advice. We haven't done an MRP run. However, the system will calculate that with that 5,000 requirement, we'll see that we are short 1,196 cases. If we run MRP on this particular component, we'll get the following results. MRP will create two planned orders on exactly the same date for 1,240 cases, which will bring our total inventory to 5,044. That's enough to meet the demand on that date based on what's input as the independent requirement, leaving an inventory balance of 44 units. The FX lot sizing procedure creates one or more planned orders for the specified quantity until demand is met. This may or may not make sense. For example, in the case of producing beer, we may want individual planned orders because we'll want to create individual production orders so that we can track each batch of beer separately. We may want to measure production dates, who was involved in the production, specific gravity readings, other measures of the beer as it's being produced for quality control and management purposes. So in that case, it may make sense. But suppose this is an item we're purchasing. We wouldn't want to have two separate planned orders that would be converted into two separate purchase requisitions to make two separate purchase orders. We wouldn't want to send two purchase orders to our supplier with the same quantities and the same dates. It's likely our supplier will hopefully call us up and ask us why there's two orders for this. Why isn't there one single order for 2,480? Or might assume that that second one is a duplicate that was accidentally sent. So for purchased items, the FX lot sizing process typically doesn't make sense. The fixed order quantity, FX in the SAP system and the simulation creates multiple orders. When you need more than a single production order quantity. When defining FX, it's both a lot sizing method and a quantity that need to be specified. Another very common lot sizing procedure is lot for lot, also abbreviated LFL or L4L. In the SAP system, this is called EX, short for exact lot size in German. With EX, the lot size is exactly what is required. So what we'll do is look at our previous example when we had FX with a quantity of 1240 and specify EX. With EX, no quantity is required. So in the simulation, we have FX as our current lot sizing procedure with a fixed quantity of 1240. That will be changed to EX, and none of these parameters is required. There's no number that's associated with the EX lot sizing procedure. This is the stock requirements list that was produced from the MRP run, assuming FX with 1240. It gave us those 2 production orders to get enough beer to meet the planned demand of 5,000 cases and leave us with 44 in inventory. After running MRP with EX, those 2 planned orders are replaced with a single planned order for exactly what is needed, brings inventory exactly to 5,000, which is what's needed, leaving a balance of 0. With EX, the available quantity should normally be 0. With EX, we're making exactly what we need when it's needed. So this, for example, would make sense in a make-to-order environment where we're having customer orders and we need exactly what is needed for that customer order. We don't want to maintain an inventory of material like we do in the make-to-stock environment. If we look back at FX and we create multiple orders, again, that may work for internal production, but suppose it's to purchase a component. Or for other reasons, we may want to make just a single production order, but a multiple of a particular quantity. So let's suppose that we want to create production orders that are multiples of 1,240 cases for ArborCress. So instead of having individual orders, we want one single order, but always to be a multiple of that 1,240. We can use the EX lot sizing process to do that by just adding a rounding quantity. So in the parameters, we currently have EX with no parameters specified. We change that to EX with a rounding quantity of 1,240. That says make exactly what you need, but make it a multiple of 1,240. So you make whatever's needed to take care of the order that is a multiple of 1,240. This is the result we had with just a pure EX with no rounding quantity. We're going to make exactly what's needed to get us to 5,000. That's exactly what's needed according to the independent requirement, leaving us with 0. When we change to EX with the rounding quantity, our planned order quantity is increased to 2,480. That's 2 batches of 1,240, bringing us to 5,044 and leaving us with a balance of 44. This is the same ending inventory as FX, except we have 1 planned order rather than 2. Instead of 2 planned orders of 1,240, we have 1 of 2,480. Again, in the MRP planning process, lead time is important to determine when a purchase order or production order needs to start. Lead time is expressed in days in MRP planning systems. So MRP is appropriate for products that are not made just in time or very high production, say manufacturing of cereal or other consumer products. It's for longer lead time, slower production processed items. One of the things that MRP will do with the lead time is determine the order start and order finish dates. Again, lead time does not consider capacity. In practice, much of lead time may be waiting in queue or waiting at particular work centers when you're talking about a more complicated manufacturing components. If lead times are specified that are too short, this will result in expediting on the shop floor. Production supervisors will start to put rush tags on certain orders that are becoming late and overdue because the lead time wasn't long enough. Soon those rush order tags are being superseded by super rush order tags of a different color as more and more expediting leads to more and more confusion. Conversely, if lead times are too long, orders are released too early in the production facility, too much work is on the shop floor, backing up and requiring extensive material handling. Managing lead times is challenging because they depend on capacity. The more capacity there is, the quicker things get through the facility. The more capacity is being used, the slower things get through the production facility. This is one of the reasons material planners are important in the MRP planning process, to make adjustments in when to actually release production or purchase orders after the MRP planning process makes its recommendation. Again, the MRP planning process creates plans or recommendations. The material planner uses judgment to execute them. When we look at the lead times, the demand comes in either as independent requirements for the make-to-stock order environment or customer orders for the make-to-order environment. This becomes the finish date for the product. Backward scheduling is used to calculate when the order should start, so there's exactly enough time to complete that order on time. In the MRP planning process, if the required date, which is the order finish date, is far enough in the future that backward scheduling using the lead time creates an order start date that is in the future, everything's fine. However, if the required date is too close to the current date, so that backward scheduling creates an order start date that's in the past, we have a problem. What MRP does as our friend is to forward schedule the order to show us the extent of the problem. What MRP will do is say, if you started today and using the lead time that you specified, this is when the order will be finished. And that difference is how much trouble you're in, how late your order is going to be. In some cases, production planners and shop floor supervisors can get together and decide to run overtime or to expedite orders to make up this gap. In some cases, that can't be done. For example, in fermenting beer, there's no way to speed up the yeast fermentation process. So this gap is something that needs to be communicated to the sales function, to the customers, to let them know that we have a problem. To illustrate this, in the stock requirements list, the independent requirement for 5,000 cases is changed to January 10th. In other words, it's needed 10 days in the future when our lead time is 15 days. When we click on Run MRP, this will produce the following result. MRP will say, if you started today, I calculate 1, 2 weeks plus a day, 15 days in the future. It can be available on the 16th, assuming there's nothing you can do about speeding up that lead time. It will show that order arriving on the 16th. There'll be an exception message. In an SAP system, there are a number of 2-digit exception codes. In the simulation, we have one simple exception, expedite, try to make something special happen. And by looking at these two dates, it's very easy for the scheduler to say, we're going to be 6 days late. It's very important to remember that capacity is not considered in MRP planning, except as add-on tools that most companies tend not to use. To illustrate this, suppose we create an independent requirement on the 19th for 15,000 cases. The 19th is more than 15 days in the future. After running MRP, MRP will create a series of planned orders, a series of suggested orders that will get the inventory up to, in this case, 16,204 cases, which is enough to meet the demand from the independent requirement and leave a balance of 1,204 cases. Because the lead time is greater than 15 days, MRP does not suggest that there's a problem. But there is a problem. In the case of Arborcrest, we only have 4 fermenters, and so trying to get this many planned orders completed in 19 days is not feasible. This is why material planners are required for MRP systems. Another factor that's not included in the Arborcrest simulations is calendars and working days. For things that are made internally, we need to consider whether there are working days or not, if in fact we're not working 24/7, 365. Yeast works 24/7, 365, so while bottling and brewing may end up being restricted to days and weekends, the simulation with Arborcrest does not include weekends and holidays. It is, however, important when you do have weekends and holidays to factor those calendars in. SAP in the simulation, like most of the rest of the world, looks at the week as beginning on Monday and ending on Sunday, so that we're working for the weekend. Also in manufacturing, it's frequently common to number the weeks throughout the year so that we're in week 5, 6, 7, and so on to refer to different planning weeks. In this case, we have a facility that's taking Saturdays and Sundays off, also Martin Luther King Day and January 1st. Suppose we have an independent requirement on the 22nd and an item takes 10 days to produce. Counting back 10 days is not merely counting back 10 days, but we have to consider the calendar. So as we backward schedule, we'd count 1, 2, 3, 4. We'd have to skip Martin Luther King Day in the weekend. 5, 6, 7, 8, 9. Skip the other weekend. And 10 would finally be on the 5th. So weekends and holidays, when they impact production, can dramatically increase the lead times for a product. In SAP, as well as a simulation, in-house production will consider the calendar for planned orders. In the SAP system and the simulation, procurement does not consider the calendar when calculating requirements or purchase requisitions. The reason this happens is that different suppliers have different calendars. Some suppliers might work Saturdays, might take different holidays, and managing those calendars when there may be thousands of suppliers is a difficult task. So it's up to the material planner to understand when holidays come up, for example, when we're getting close to Thanksgiving, that purchase orders and purchase requisitions should be adjusted to allow for holidays and weekends and busier periods.